Okay, kids, two more questions. A pole has a wire attached to the top of it, which extends to the ground. Pole. Ground. An assumption. The pole is 90 degrees with the ground. The wire is pulled tight and is pegged 7.9 meters away from the base of the pole. Base of the pole. Top of the pole. Wire being pulled down and pegged 7.9 meters from the base of the pole. So this is P for pegged, and this is your wire. There you go. As soon as you do that, you need to go and put in your numbers. The angle of elevation that the wire makes with the ground wire, angle of elevation is going up 35 degrees. Find the length of the wire to the nearest tenth. Okie dokie. So the wire I'm going to let be x. So I'm going to say that this is adjacent. That is hypotenuse. Adjacent and hypotenuse is cosine. So cosine of 35 degrees is going to be the adjacent side divided by the hypotenuse. Notice my unknowns on the bottom. So we have to come up with a way of dealing with this. I personally think one of the easiest things to do is to cross multiply. Noticing that 1 times 7.9 is just going to give me 7.9, and then divide both sides by this number, which is going to be... Some of you are just going to skip right to here, but this is the math that's going on. We do the cross multiplying, and then we divide both sides by that number. Either case, you got to be able to do it. 7.9 divided by 35 cosine. Okay, so be careful here. 7.9 divided by 35 cosine. When I do 35 cosine, that is the decimal of 35 cosine. I then have to hit equals, so it does the division. So it equals approximately, to the nearest tenth, 9.6 meters. Okay. The other way to sort of think about this one, if you really wanted to, and I do sometimes, when you look at it set up like this, if you have two fractions, so if I have 2 over 3 equals 4 over 6, you'll notice that if I flip both of them, so 3 over 2 becomes 6 over 4, the fractions stay equal. There's no difference there, as long as I flip both sides. So sometimes what I do is, starting from here, I'll go 1 over cos 35 equals x over 7.9. Then I do the cross multiplying. I multiply both sides by 7.9, and I get x equals 7.9 over cos of 35, and it takes me to the same point. And so it really doesn't matter. The flexibility might be appreciated by some, but pick one and work with it and become good at it. Okay, example number 4. We'll finish this off. An airplane is flying at an altitude of 7 or 500 meters. Okay, already, if I'm going to have an altitude, I need a ground. If I'm going to have an altitude, I got to have up in the air. So I've got a plane, and the airplane is traveling at an altitude of 500 meters above the ground, and that's going to be from directly underneath the plane. The angle of depression from the airplane to an airport. So we have an airport out here. The angle of depression, so from the plane, the angle of depression, first of all, you need a horizontal, guys. Without the horizontal, you're not going to have an angle of depression. So there's your angle of depression. That's my horizontal. Notice the horizontal is the same as the horizontal of the ground. That's how we got it. We could draw horizontals anywhere we want, but this one's the important one. All right, so that's going to be theta. That is your angle of depression. That's worth a mark. I need to see that. Now, the fact that this and this are parallel allow the Z pattern to happen and allow me to do T, P, T, Z pattern. Yes, I'd like you to put that in, please. Okay, so I've got an angle here. The angle of depression is 3.4. It's a pretty small angle. And what we're looking for is, what is the direct distance from the airplane to the airport in the nearest kilometer? Now, direct distance, that's an interesting question. So the direct distance is going to be the the actual distance. If you are able to go directly from the plane to the airport, that's that distance. That is the hypotenuse. That's the direct distance from where that person is on the plane to where the airport is, okay? That would be the horizontal distance along the ground. But remember, you still have some distance up on top for the airplane. So direct distance is from the plane to the airport, so that's going to be the hypotenuse. So direct distance. And we're going to call that x, for lack of anything better to call it. Okay, so off we go. I've got an angle, I've got an opposite, and I've got a hypotenuse. Sounds like sine to me, people. So sine 3.4 degrees equals opposite over hypotenuse. So again, looking at this, I like to make sure I see it as a fraction equals a fraction. I'll do it this way this time because it's just so much fun. So I flipped both sides. Remember, I need to get that unknown in the top. That's where it needs to be. And then I'm going to multiply both sides by 500. Then I'm going to grab my calculator. And I'm going to go 500 divided by 3.5 sine equals. And x equals approximately to the nearest kilometer. So it's going to be 8,190 kilometers. Ladies and gentlemen, that's it for me. You got some practicing to do. Good luck with that. Send me any questions you have.